Hello students, welcome to Sort of Search classes. The problem that we want to solve today says an is a sequence of positive real numbers such that limit n goes to infinity a into the power 1 by n equal to 1 by 4. Then there's a function given, a fairly complicated expression with sine and 1 by x and a log. It says that this function is continuous but not differentiable at 0, continuous everywhere except 0, differentiable at x equal to 0 and nowhere differentiable. These are the four options. Now let us see how we solve this problem. Firstly, to check continuity, limit x goes to 0 fx. So limit x goes to 0. What is fx? It is x sine 1 by x square. Now as x goes to 0, 1 by x goes to infinity, sine oscillates and x dominates the function, which is equal to 0. So limit n tends to infinity, log of 1 plus an by sine an plus pi by 2. This is what f of 0 is. Now we have to actually find this, what this thing is. Now since limit n goes to infinity, log an to the power 1 by n is equal to log 1 by 4. We have log of limit n goes to infinity an to the power 1 by n equal to log 1 by 4. Now this 1 by n, this 1 by n comes outside as a scalar, and let us just for convenience take all these logs to the base 2. So as n goes to infinity, 1 by n goes to 0, so log 2 of limit n goes to infinity an has to go to 0 if this limit has to be finite. This is equal to 0, which implies 2 to the power 0, which is 1, equal to limit n goes to infinity. So I think I just made it a bit too haphazard here. I'll just erase it and do it fresh. So we knew that limit n goes to infinity, log 2 an to the power 1 by n equal to log 2 1 by 4. Limit as n goes to infinity, 1 by n log an is equal to minus 2, which is log 2 1 by 4. Now as 1 by n is multiplied by log an here, it's just log an by n. N goes to infinity, log an has to go to minus infinity as n goes to infinity. It has to diverge, because otherwise the limit cannot be finite, and it has to go to minus infinity, because if it were always positive, then both these terms would cancel out, and both these terms divided would not give us a negative limit. So log an goes to minus infinity as n goes to infinity, which implies an goes to 2 to the power minus infinity, which is 0. So limit n goes to infinity, an is 0. Now if we put it in this limit, if an goes to 0, log 1 plus an goes to 0, and sine an plus pi by 2 goes to sine pi by 2, which is 1. So this is equal to 0. So it is continuous at 0. Now we have to check differentiability. Limit h goes to 0, f of h by h is equal to limit h goes to 0 sine 1 by h square, which of course does not exist because sine 1 by h square is a oscillating function as 1 by h goes to infinity, therefore not differentiable at 0. So we have this option continuous at x equal to 0 but not differentiable at x equal to 0, and this is the correct answer. We move on to the next problem now. The next problem says, what is the value of the limit x goes to half integral of half to x cos square pi t dt by e to the 2x by 2 minus e times x squared plus 1 by 4. It's a fairly complicated expression. Now what is cos square pi t? As x goes to half, the numerator goes to 0 because it's integral from half to x, and as x goes to half, the denominator, it is e to the power 2 into half is e to the power 1, which is e by 2 minus e into half. So e by 2 minus e by 2 is 0. So the numerator goes to 0 and the denominator goes to 0. If something like this happens, we only have one answer, Lupita's rule. So Lupita's rule applied once gives us, before that, if f t dt integral of half to x, the derivative of this, if this is gx, then g prime x is equal to fx minus f half. So this just gives us cos square pi x minus cos square pi by 2 by e to the power 2x times 2 by 2, which gets cancelled out, minus e times 2x as limit x goes to half. Now cos square pi by 2, drawing the graph of cos pi by 2 is 0, so cos square pi by 2 can as well be erased. Cos square pi x as x goes to half is 0, and e to the power 2x is e minus e times 2x is e, so even this is a 0 by 0 form. And once again we apply the L'Hospital's rule, Lupita's rule, to get 2 cos pi x minus sin pi x times pi by 2 e to the 2x minus 2e. As x goes to half, once again cos pi x goes to 0, and we once again have a 0 by 0 form. The third application of Lupita's rule, before that we'll just simplify this. This is equal to limit x goes to half 2 cos theta sin theta is sin 2 theta, so we have minus pi sine 2 pi x by 2e to the 2x minus 2e. So now applying Lupita's rule again, we get limit x goes to half minus pi minus 2 pi, rather the 2 comes out, cos 2 pi x. I'm sorry, this is minus 2 pi square because a 2 pi comes out and you have a minus pi here. Now here we have 4e to the power 2x. So this is no longer in 0 by 0 form, rather this gives us a 4 pi square above and a 4e below, which is pi square I beg your pardon, this gives us a minus 2 pi square above and a 4e below, which is minus pi square by 2e, and the correct answer is D, minus pi square by 2e. Now we will move on to our next problem. The number of distinct eigenvalues of the matrix, okay, it's a 4 cross 4 matrix which every entry 1, the number of distinct eigenvalues of this matrix. Cool. So now let us just not waste time in finding out its characteristic polynomial and see what we get. We get w plus x plus y plus z, 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 which is equal to w plus x plus y plus z times 1 1 1 1. Now this, if it's equal to some k times w x y z, we have kw equal to w plus x plus y plus z, kx equal to the same, ky equal to the same, and kz equal to the same. Adding up all these 4 equations, we get k times w plus x plus y plus z is equal to 4 times w plus x plus y plus z. Therefore k has to be equal to 4. Now rank of the matrix A is equal to span of 1 1 1 1, which is 1, the dimension of this, which is 1. Therefore dimension of the kernel is equal to 3, and of course 4 is another eigenvalue. Therefore 2 distinct eigenvalues, which is 0 and 4, and B is the correct answer. If you like the video, please press the like button. If you have any doubts or queries, please post it in the comment section. Please subscribe to our channel for more such videos. Thank you.